Determine how many one-to-one correspondences are possible between two sets STZWV and 1, 2, 3, 4, 5, given the following conditions. A. If in each correspondence S must match with 5. B. If in each correspondence S must match with 5 and T must match with 4. C. If in each correspondence S, T, and Z must match with an odd number. So, how many one-to-one correspondences are possible between the two sets if in each correspondence S must match with 5? Okay, so if no special restrictions were placed on the sets, there would be 5 factorial, or 5 times 4 times 3 times 2 times 1, which is equal to 120 different possible one-to-one correspondences, since there's 5 in each set. Now, there is a restriction because S must match with 5. So if that S must match with 5, then how many choices are left for T? Well, for T, we're going to have 4 choices. Okay, so then how many are left for then Z? For Z, then that means that there's only going to be 3 choices since 1 is removed. So therefore, for each of the possibilities, so we have 3 choices for Z. Now, if we take a look at W, how many choices are left for W? Well, that means now there's only 2 choices left, since we only have 2 choices left. And then for V, we only have 1 choice. So what does that mean here? Well, that means that therefore there are 4 times, in this case here, we have 4 times 3 times 2 times 1, which is the same thing as 4 factorial, which is equal to 24 possible one-to-one correspondences. Now, how many one-to-one correspondences are possible between two sets if in each correspondence S must match with 5 and T must match with 4? So if we know that S must match with 5, okay, and we know that T must match with 4, okay, so then what does that tell us? Well, that means that we have 1 choice for S. We have 1 choice for T. Now, the next letter is Z. So how many numbers are left? Well, that means that there's 3 choices for Z. The next letter is now, and let's just say we picked the number for Z, and we said that there was 3. So now, if we look at the next letter, which is W, how many choices are left for W? Well, there's 2 choices that are left for W. So if we take that 1 choice, then how many are left for V? Well, that means we have 1. So if we have the numbers 1 times 1 times 3 times 2 times 1, that equals 6 possibilities. Now, how many one-to-one correspondences are possible between two sets if in each correspondence S, T, and Z must match with an odd number? So, how many choices are there for S? Well, for S, there's 3 odd numbers. So they have 3 choices. So there's 3 choices for S. If I take 1 odd number away, then how many odd number choices now are left for T? Well, T now has 2 choices. Okay? Since 1 is already matched. So if I take T and I have 2 odd choices, now I'm going to take that 1 away. Now there is 1 choice of odds left for Z. So if I take that Z, then there's another odd number there. Now, so far there are 3 times 2 times 1 possibilities. Now we need to take a look at the other 2 possible choices. Now for W, there are 2 possible choices. So there's 2 possible choices left for W, either 2 or 4. if we select 2, then what does that tell us about V? V tells us that there are one choice left for V in the second set to match with V. So therefore, we have 2 times 1. So we would have 3 times 2 times 1 times 2 times 1, which is equal to 12.